In the last video, you were discovering the beautiful, wonderful world of quality batches. I just opened up a whole new can of worms. And for some people, this is like misery. But you know, this is a requirement. And it's a requirement because we've got to feel extremely good about the data that I'm generating in the lab. And the only way that we can do that is we go through and we figure out how many checks can I put into the batch to make sure that things are still going according to plan. We've talked about a measly 3. We talked about the calibration. We've talked about the initial calibration check, and then we talked about continuing calibration checks. And I also said, listen, you know, sometimes people, if it happens at the end and no more samples are coming around, and then we do an end one for real, an end one, then we abbreviate that as the ECV, the end calibration verification, just to have maybe some insight that, yeah, this is formally where this batch is going to stop. All right, so number 4, this is where we're picking up more QCs. Calibration blank verification. So a calibration blank verification says this should be run after the ICV and the CCVs. Notice it says it should be less than the CRDL. Oh no, I forgot what that stood for. Contract Required Detection Limits. Notice in the table from up above in another video, you saw it too. So we hope that when we run blanks, aka distilled water, when we place them on the machine, that distilled water could have a value. It could report a number, absolutely. And we want to make sure that the blank is lower than the detection limit that I'm stating that we can go to. Notice it says after the ICV and CCVs. Folks, the reasoning here is that the blank should actually not carry any contamination at all. And if it does carry contamination, then we question, like, how much will it carry? And what I'm hoping to say and to demonstrate is that the blank, the calibration blank that we are running, this verification that's treated as a sample, is going to be going in and we're solving for like how much is in the blanks that we are using, those solvents that we're using, aka water. And we hope that there's hardly anything at all. We don't want that blank to contribute anything to all of our calibration curves, all of our standards that we have made with it, and so on. That's a problem. So we got to show, yep, our blank is clean. Notice it says it should be less than the detection limit. Okay, my blank should not have anything greater than a 2. That's what this is. If it is, it's not necessarily a blank. It's contaminating it too much. You got an issue, you got a problem. Number 5. So this means calibration blanks are going to have to be ran throughout the batch. And what you're going to see us do is that when we take blanks and when we run them, we're going to be running them as samples. Absolutely, that's the way that we're going to process this. But we are going to take the okay to run blanks whenever we think is the most convenient. We're not going to be running them every single time in the appropriate things that we need to be doing. But we're going to kind of stay true somewhat to the table that you see here for sure. So I've probably told you in your directions when you finally get them and read them to prepare many, many blanks. And this is why we need to scatter them throughout the batch. Maybe we don't use as many as what the method is going to require us to do. But, you know, they need to be there, and we're going to run them. We might not have as many, but they're going to be present. So do not think that you read wrong when you see the number of blanks that you should be preparing. Number 5, and give me a break. Prepare the blank. I mean, come on. You squirt some water in a TOC container and you put a lid on it. That's preparing the blank. So don't give me any lip about, oh no, all this work that he makes me do because I've got to make, 12 of these. No. You just squirt some water in the vial and you put a lid. You got the easiest job ever if that's what you got to do. Number 5, CRDL verification standard. What is that? Well, notice it says less than 2 times the CRDL. Okay, so for this particular type of table, for the contract, it says 2. So the contract verification standard is going to be less than 2 times 2, which is a 4 ppm. So what this means is that I'm going to be preparing another quality control sample that's going to be added to the batch, and this is a verification standard, and it's going to be less than 4 ppm based on the contract that we see here, because it tells us the CRDL is 2 ppm. So less than 2 times that value. If it was a contract value of a 1, okay, 2 times 1 is 2. I need to make something lower than 2. I need to run it. Here it says after the initial CCV. Oh my God. I've got calibration standards. I've got initial checks. I've got continuing checks. I've got blanks after the ICVs and CCVs. And now I've got a verification standards for CRDL that I need to insert into this after the first CCV that we run. And I haven't even made it to samples yet. Nope, that's pretty common. And notice it says plus or minus 20% from the expected concentration. So yet again, a threshold. And this threshold is on the lower end of the detection limit that we are claiming that we can report. And because it's on the lower end, things get a little weird down here. These numbers are very often smaller. Little bit of variation here can make a massive percent change if you're not very careful. So the threshold window opens up for us a little bit, just to give us that extra wiggle room. So if things do change very, very tiny, but maybe that will lead to a large percentage. If the calibration blank fails, we are going to terminate everything. We identify and document just like before. We recalibrate, verify, and reanalyze everything. If the verification standard for the CRDL fails, then we're going to prep, we're going to reanalyze it, and then we're going to recalibrate and verify if needed. More hurdles, more things to overcome. That's like life story, isn't it? All the things you have to overcome before you have fun with the samples. Folks, this is just one table. As I scroll through the document, you're going to see another table that has extra things that we need to do. So we need to talk about these too. Next is a method blank. And a method blank says 1 per batch or 1 per 20 samples minimum. Our method blanks need to be less than the CRDL, and for this particular table, that's 2 ppm. If the lowest sample concentration is more than 10 times the blank, then no action is needed. If samples are non-detected, no action is going to be needed. And if the detected sample concentration is less than 10 times the blank, then all associated samples have to be prepped again with another method blank, and we've got to reanalyze them. All right, so let's say that we run a method blank, and our blank is going to be running a 1 ppm here. Okay, not a big deal. That's the number that we get from it. Maybe it's not super clean water, so it's a 1 ppm. So these directions over here state that and that is, look, that's less than the contract detection limit of a 2. Okay, so it's okay there. But look, it says if the lowest sample concentration is more than 10 times the blank, then there's going to be no action needed here. So if you used a blank and it's came in contact with the samples and whatever the case might be, if that is more than 10 times, 10 times 1 is 10. So if it is 10 part per million or greater, oh, not a problem. Keep going. If the samples are not detected, so if I do this and it's basically below our threshold, keep going. Nobody cares. But number 3, it says if the detected samples are less than 10 times the blank. So if this is going to be less, in this case, in this example that I've done, less than 10 ppm, and our samples are reading 4 ppm, 3 ppm, 5 ppm, and so forth, then everything has to be prepared again with another method blank and reanalyzed, because that's contamination and it's messing with our results and it's messing with our values. Number 7, a dupe. A sample duplicate just means you do it twice. Notice it says all samples in the batch have to be done. We have a percent threshold here. It says less than 20%. Blah, 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 blah. We'll talk about that on a different day. Number 8, we have a metric spike. Notice it says 1 per batch or 1 per 20 minimum. We get a threshold of 25% that's there. And then next is number 9, and it's a lab control sample, aka QC. 1 per batch, 1 per minimum of 20. And then again, another threshold of plus or minus 20%. If the QC sample does not work, under the corrective action column, it says terminate Arnold Schwarzenegger. No, that's Terminator. Identify and document the problem and reanalyze. I mean, folks, it's like the year of COVID. I mean, every time you turn on the TV, it's like, wash your hands, wash your hands, wash your hands. You fix everything in the world that's going wrong if you just wash your hands, wash your hands, wash your hands. And that's what this table is doing. It's saying terminate, 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 identify, 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 reanalyze, reanalyze, reanalyze. That's like the solution to everything. Terminate, identify, and reanalyze. Wash your hands. Notice it says SDG quite often. You know, what does SDG actually mean? What is that? SDG is this idea. Down here at the very bottom, you see this. It says, and look, I'm doing erasers instead of highlights. Sorry. So SDG. Here's an SDG, and it says sample delivery group. Each case, field samples are received, or each 20 field samples within a case. That is what a sample delivery group is. So this is kind of their way of saying a batch. And if it's got more than 20, then we need to kind of break that up a little bit. We're only going to kind of go max out at 20. And then we kind of go to the next one and handle that in a different batch. So it's really kind of limiting us on the number of samples that we can be running in a batch at one time. We can't just run 100 samples and call it a day. That's not how any of this works. We can't just have 100 samples get donated, run 100 samples, pretend like all of these other kind of things don't exist, and then just whatever number shows up in the report, just send it out and kind of give the data. No, that is not what goes on. And then that ends the document. So what's going to happen in the next video, I'm going to show you a little bit of our data tables and our data prep forms. And now that you have some background about these types of samples that are going to be required, I think that now you're going to understand the creation of those forms a little bit better and know where things are, why things are located the way that they are in the form as we go through the sample preparation and then reporting the data on the very end of this. So in the next video, we're going to pick up with our data sheet, and we're going to talk a little bit about the prep that I'm going to do on day 1 when I go into the lab and actually accomplish this for the first time. All right, so I'll see you soon. Look, 14 minutes. Well,